Hi all, today we'll be covering Kubernetes, and in this playlist we'll be covering from intro to the advanced level of Kubernetes like ingress, RBAC, liveness and resource management. Let's get started with the introduction. Coming to the prerequisites of Kubernetes. Yes, there is prerequisites. You should be knowing Docker and Docker Compose. Docker knowledge is a must, whereas Docker Compose is optional. Docker Compose is again an orchestration tool, just like Kubernetes. So, if you know Docker Compose, you can easily correlate what's happening in Kubernetes. And Docker knowledge is a must. You should know how to run a container, how to start a container, or how to stop a container, how to build a container. Yeah. So coming to what is Kubernetes or K8s. So Kubernetes is a container orchestration tool. And so next question is, what is container orchestration tool? So it's a tool that is used to manage, scale and maintain containerized applications. So again, Docker Compose is another example of a orchestration tool. So how is it different from Docker and Docker Compose? The thing is, Docker Compose or Docker is meant for a single host deployment or a simple deployment, whereas Kubernetes is meant for multi-node real-world applications. Let's say an enterprise is deploying a service, they will surely go with Kubernetes instead of Docker. Another differentiating factor is K8s is internally having master and worker nodes. It supports RBAC. This is role-based access control. DRA is disaster recovery. HA is high availability, replicas, and load balancing. All these enterprise features are supported in K8s, whereas it's not supported in Docker Compose. And most importantly, you can easily remember like all the scaled production, all the enterprise production settings will be going with Kubernetes, and all the internal deployments can go with the Docker Compose. Coming to the architecture of K8s, this is a very simple architecture of K8s. So we have a client piece as well as we have a server piece. Server piece is internally having control plane and data plane. So this is the client piece and we have a server piece. Need not look into what's going inside. You have the controller, server and the scheduler. So proxy, kubelet, all these things are there in the server side, but you should be remembering like there is a client piece and a server piece. I mean, there is no point. I mean, there is advantages of understanding what goes into it, but that's out of scope for this session. So there is a client piece and there is a server piece. So all you need to know now is K8s, there is a K8s server and there is a K8s client. And the K8s server spins up services or Docker instances on demand and maintains the state of all worker nodes. That's one. And K8s client is also called kubectl or kubectl. So kubectl client allows us to interact with the server. So you have the client piece, which is the kubectl, and that interacts with the kube server, and kube server internally maintains all the state of the worker nodes, all the states of the running nodes. So additional fun facts. So it is open sourced. Again, Kubernetes is maintained by Google. So cube and there is 8 letters, that's why K8s. So it's much better than Docker Compose deployment, even though there is an overhead. When you are studying Docker, you might not understand the need for Kubernetes. Once you are into any production scale setting and understand how Kubernetes works, you'll never go back to Docker Compose. The first option that you'll prefer for sure is Kubernetes. Hi, in the next section we'll be covering installation. So there are many implementations of K8s. There are full-blown K8s services like EKS, GKE, Azure Kube services. So EKS stands for Elastic Kubernetes Service, and GKE is the Google's Kubernetes engine, and K3S, K3D, RK2, Kind, and Minikube. My personal favorite is K3s and K3d. These are meant for single host deployment of Kubernetes, and even within these two, my personal favorite is K3d. K3d is K3s on a Docker container. So these are the three softwares that must be installed. One is Docker, and then the K3d, which is a server piece, and we need to install kubectl, which is a client piece. So go to the Docker engine, and you need to install the Docker engine, and you need to select the operating system. Mine is Mac OS, so I can just download the Docker desktop for Mac with Apple Silicon, and it installs the DMG file on my machine. Same goes for the Windows, and again Windows will have a desktop application, so you can just download it and run it. So that's with the installation of Docker engine. So the next piece that we need to install is the K3d. K3d installation is fairly simple. All you need to do is just run this one single command, and it installs the K3d for you, the server Kubernetes server for you. It's fairly simple. I mean, all you need to do is just run this single command, and it installs the entire Kubernetes server for you. So coming to the next piece, we need to install the client piece also, which is a kubectl. So just go to the link. Again, select your operating system, which is a Mac OS, and you need to run this single command that installs the client piece, the kubectl piece. So it's fairly straightforward. You can see installing server is a single command, installing client is a single command. That makes your journey to Kubernetes much easier. That's it with the installation, and in next session we'll be covering pods, which is a fundamental unit of Kubernetes engine. Before getting started with the next section of pods, we need to run few commands to configure the K3d environment. So we'll go to terminal, and let me increase the size. And the first command that we need to run to configure K3d is to create the cluster. So run this command, and it creates the cluster, my cluster. You can see it installs all the containers that are required for the K8s environment. So it installs the server load balancer, server tools, it configures the DNS. So it created the cluster. So that's one, and now we need to check whether everything is running properly. So get pods -a, and you can see these containers are getting created, and we can run it again to see it's still in the creation phase. It takes around 1 minute for the cluster to get configured properly, and just keep on running. Get pods -a, see some changed into the running state, and once every container is in completed or running state, we can know now all the containers are in the running or the completed phase status, so we can be sure that the K8 server is configured properly. So that's one. Next thing, get back to the pods. So the K8 server and the client piece is configured properly now. So what are pods? So pods are almost similar to the containers, but pods can contain multiple containers. That's the difference. The functionality of pods and containers are similar, but pods can contain multiple containers. Generally, the additional container or the sidecar or the init container are used for logging and initialization purpose. Example is a fluent bit container with the server container for logging. Conceptually, it serves the same purpose, and it is same and it serves the same function. Let's get to the meat of Kubernetes, how to create one pod. So here is an example of converting Docker command to the pods.yaml file. So this is a sample command, Docker command on how to start an Nginx container. So we'll be replicating the same in Kubernetes.yaml file or the pods.yaml file. So unlike Docker commands, you are not supposed to by heart the template of Kubernetes file. If you by heart it, you are supposed to make mistakes. So what you are supposed to do is you need to search for KTS pods.yaml file, and it gives you the base template, and you're supposed to make modification on the base template instead of by hearting yourself and making mistakes. When you're copying, all you need to look for is the specific sections of the template file, like the kind, what is a container name, what is the image that we are going to provide. So we'll be copying it. You need to copy it, and we'll come to the terminal. So we'll start by creating a folder KTS and cd KTS. Okay, so KTS okay. Okay, I should be running it and fine. So we'll go to the pods.yaml file. We'll create a pods.yaml file, and we will paste the content of the YAML file. Let's get to the Notion. So here we are trying to pull the Nginx latest image. So we'll change the image to latest. We'll pull the latest image, and then we'll expose the port 80, similar to the Docker command, and that's it. We have to look for the kind is pod, so that makes sense, and we are providing the name Nginx. So we'll save this file and ls, and we have this pods.yaml file. So how do you create the pod? So whenever you have a YAML file, the command is same in Kubernetes. So it is kubectl apply -f pods.yaml file. So you do that, and the pods get created. So let's check whether the pod is created or not. Get pods, and you can see the Nginx is running. Now let's try to ping the Nginx server. So localhost 80, bang, you are unable to connect to the pod. Unlike in Docker, unless you provide a networking to the pod, you won't be able to connect it from the localhost. So but we need to verify, right, whether it is running or not. So let's do one thing, kubectl get pods, and you can see Nginx is running. So how do we check? Similar to the docker exec command, we have the kube exec command. So kube exec ti, the name of the pod is Nginx, and you have to run bash. You can see I got into the pod, the root pod. Okay, so ls, now I can run localhost 80. Now you can see it is serving the Nginx web page. So that means Nginx is running, everything is working fine, but we haven't connected the network to the pod yet to access it from outside networks. Exit. So we are outside of the pod. Now let's see how to delete the pod. So kubectl delete pod, and it is Nginx. So you can see it deleted the Nginx pod. And let me see. So what else is there? So further rates, you can read more about pods in this link. I'll share this HTML file or the PDF of this presentation later. In the last section, you might have seen me entering a lot of kubectl or the kubectl commands. You might find it difficult to follow it. So, I'll be explaining what kubectl does. So, kubectl is a client that interacts with the K8s server. So, the most common kubectl commands that we use are the kubectl get, delete, describe, logs, and exec. It's good that you by heart or understand what this commands does, and one important one is apply -f and the file name .yaml file. So kubectl get is used to collect all the resources. We'll come at a later stage what these resources are. So delete resource, whenever you are deleting, you need to specify the resource and you need to specify the resource name, as well as when you are trying to describe something, you need to specify the resource and resource name. And when it comes to logs and exec, you just need to provide the resource name. So resource name is nginx, and resource are pods, services, or deployments. So there are a lot of resources that are available in Kubernetes. So when it comes to get, you need to specify the resource type as a whole, like pod, get pods. So let's look what all resources are available. So the most important resources are pods, deployment, replica set, service, ingress. You can read more about this later, else this video will be way longer. So most important one is pod, most important one is deployment, services, ingress. Other common resources include config map, secrets, persistent volume claim, job, cron jobs, stateful set, daemon set. So these are the available resources. So let's construct the command. So let's say if you want to get the pod, kubectl get pods. Let's say you want to delete something, delete a pod, kubectl delete pod. Okay, let me add it here, that will be better. So it will be like kubectl get pods. Okay, there will be additional parameters also that you can learn on the go. Let's say if you want to delete something, so kubectl delete pods, or delete pod, or delete pods and nginx, the resource name. Okay, let me show you the real example. Why to type it here? So kubectl. Okay, let's start with the get. Okay, let me bring up. Okay, ls and clear. So I'll apply. It'll start from the base. So let's see, kubectl apply -f and the file name. So applying the file pods.yaml file. So you can see it created the container. So we covered the apply -f. Delete. Okay. So kubectl get the resource. So resource includes pod. So kubectl get pod. You can see it shows you the pod names. If you want additional details, I mean all the pods that are running, then you should give the -a parameter. If you are not providing any parameter, it shows all the pods that are running on the default namespace. You can look into namespaces in a separate video, some other YouTube video. You can look for the namespaces and all. It makes the things complicated. Not complicated, it's a, what would I say, logical separation of Kubernetes deployments. So that's a simple definition of namespace, logical separation of Kubernetes deployments. So let's say if you want to see something that is specific to the specific namespace, the containers that are running to the that are running in the specific namespace, let's say I'm giving default, it shows okay the ones that are running in the default namespace. Let's say if I just give, I want the pods that are running in the kube system namespace, it shows the container the pods that are running in the kube system namespace. So for now you just need to remember get, when you're using get you need to specify the resource. So another resource that we have is deployment. Let's see whether we have any deployments now. Deployment, you can see there is no resources available because we haven't created any deployments till now. So get is clear, right? Now let's delete it at the end. Okay, now let's see how to describe something, describe the pod. So kubectl describe pod nginx. You can see it gave a lot of details of the nginx pod, when it was created, when it was started, what image that we are using, or which ports it is running, which port it is exposing to the host port, so what volumes it is using. So a lot of information, and the most important piece is it gives you this logs. Let's say some pod is having trouble starting up, so how you debug is through the describe. So you run the describe pod name, and it shows you events, what all happened. If something is failing, it will show the reason why it is failing, why it is unable to pull, whether it's some network issue or something. So describe is pretty useful for debugging. So again, kubectl describe resource and resource name, that's how we provide it. The next thing is you have to get the logs. So similar to Kubernetes, similar to Docker, so kubectl logs -f, and you provide the -f. If you're familiar, it's just for following, it's not required. So you need to provide the pod name nginx. You can see it gives you the, let me clear it. Okay, kubectl logs and the resource name. Resource name is nginx. So it gives you the logs from the nginx pod. So you can see it started running. So that's with the logs. And the next thing is exec. So exec, again similar to Docker, kubectl exec ti, and you need to run for nginx and bash. You can see I'm inside the container. Now I can execute commands. I logged into the container as a root user. So that's how you run the exec. You can exit from it. And next, final one is delete. Delete again comes in the format kubectl delete resource and resource name, similar to exec. Delete pod nginx, and it deleted the pod nginx. Similarly, you can delete services deployments. We'll come to what is deployments and services later. That's it. And if you see, the reason why we just provide exec and logs to a resource name, it's because it's specific to a resource. Let's say if you are running, if you want to exec, we specifically need to exec into a pod. So there's no point in providing the resource type here. Whereas delete and describe, the same logic goes through, what you have to delete multiple types of resources with same name. So it is good to have this resource tag attached to it. So just remember these 5-6 commands and you are 90% good to go with kubectl management or the Kata server management. Get, delete, describe, logs, exec and apply. If you know this 3 plus 3 6 commands, you are good to go. And don't by heart the template for creating pods or the deployment files. So this is the end of day one. In next session we'll be going with deployments. Till now we haven't seen any real use of having Kubernetes. We just created pod, but the same thing you can do in container. Why to have all the overhead? So as we mentioned here, the deployment, when it comes to deployment, we have this additional functionality like high availability, managing replicas, disaster recovery. So we'll be seeing the real fruits of Kubernetes in the next day. Yeah, thank you. Yeah, just learn this 6 commands and you're good to go. Thank you. Yeah, bye.